Good morning everyone. Welcome back to grade 4 mathematics class. How are you all doing today? So we have already started the chapter patterns and symmetry, and we have gone through some basic concepts that you have already learned in your lower classes. So today let's talk about patterns in numbers. So what do you mean by a number pattern? A number pattern or a pattern in number is a sequence of numbers that follows a pattern rule or logic. Now look at this table given here. Can you identify some kind of pattern? See the numbers 0 plus 1 plus 2 equals 3. And the next line it is given 1 plus 2 plus 3. See here it is started from this 1. So it is 1 plus 2 plus 3 and that is equal to 6. In the next line it has started from this 2. So it is 2 plus 3 plus 4 which is equal to 9. The next line it started from this 3 and it is 3 plus 4 plus 5 is equal to 12, and it goes on like that. And what about the sum in each case? Look at the sum 3, 6, 9, 12, 15, 18, 21, etc. Now, the sum differs by 3 in each case. 3 plus 3 equals 6, 6 plus 3 equals 9, 9 plus 3 is equal to 12, and it goes on like that. Here, the sum differs by a number of 3. 3 plus 3 equals 6, 6 plus 3 equals 9, 9 plus 3 equals to 12, and it goes on like that. So, there we have a pattern that follows the multiplication table of 3, right? Now, let's see one more example. 1 plus 3 equals 4. 3 plus 5 equals 8. 5 plus 7 equals 12. 7 plus 9 equals 16 and 9 plus 11 equals 20. Look at the add-ins. Here it is 1 plus 3 and here it is 3 plus 5. Then again 5 plus 7, then this 7 plus 9, 9 plus 11, it goes on like that. You're adding odd numbers in a pattern. And what about the sum? Look at the sum 4, 8, 12, 16, 20 and goes on like that. In each case, the sum differs by a number 4. 4 plus 4 equals 8. 8 plus 4 equals 12. 12 plus 4 equal to 16 and 16 plus 4 equal to 20. Or we can say the sum, for the sum there is a pattern and that pattern follows the multiplication table of 4. Clear? So these were a couple of examples for patterns of numbers in addition. Now we'll see some patterns in subtraction. Look at the first line, 70 minus 50 equals 20. The next line, 1 is subtracted from both numbers, from both the minuend as well as the subtrahend. So 70 minus 1 equal to 69 and 50 minus 1 is equal to 49. Now they are subtracted and you get the same difference. Again 1 is subtracted from both the numbers. 69 minus 1 equal to 68, 49 minus 1 is equal to 48. Taking the difference, we get the same difference. So here 1 is subtracted from both the subtrahend and minuend and you get the same difference each time. In each line, the difference is the same because you are subtracting the same number from both the numbers, both the subtrahend and minuend. So what if we had subtracted 2 from both the numbers, 70 and 50? 68, 70 minus 2 is equal to 68 minus 50 minus 2 is equal to 48, which is equal to the same difference, 20. So it means that if you subtract the same number from both the subtrahend and the minuend and you take the difference afterwards, the difference remains the same. So that is the pattern of numbers in subtraction. Now let's see some patterns in multiplication. Here you can see the multiplication table of 3. 1 3s are 3, 2 3s are 6, 3 3s are 9, 4 3s are 12 and it goes on like that. See, can you observe any kind of pattern in the multiples? See, this 3 is equal to 0, 3. It means the same. Here it is 06, here it is 09, here it is 12, 15 and goes on like that. Here again 18, 21, 24, 27, 30. And what is 11 into 3? 11 into 3 is equal to 33. And 12 into 3 is equal to 36. And goes on like that. See, observe the numbers in the tens place. See, here 0, 0, 0, 1, 1, 1, then 2, 2, 2, then 3, 3, 3. See, the numbers 0, 1, 2, 3, etc. These numbers seem to be repeating in the tens place. And also, when you take the sum of the digits in a multiple, for example, here it is 0 and 3, 0 plus 3 is 3, here it is 0 and 6, 0 plus 6 equals 6, 0 plus 9, 9, 1 plus 2 is equal to 3, 1 plus 5 equal to 6, 1 plus 8 is equal to 9. See, if you take the sum of the digits in a multiple, the sum will either be 3, 6 or 9. So that's also a pattern. So these are a couple of patterns that you can observe in the multiplication table of 3. Now let's see the multiplication table of 5. 1 5s are 5, 2 5s are 10, 3 5s are 15, 4 5s are 20, goes on like that. And you observe the ones digit in each of these multiples. The ones digit in all the multiples would either be 5 or 0. So that is one pattern. Now observe the tens digit. This 5 can be written as equal to 0, 5. Now look at the tens digit. 0, 1, 1, 2, 2, 3, 3, 4, 4, 5. And what is 11, 5? 11 into 5 is equal to 55. So it's 5, 5. And the pattern goes on like that. The tens digit in each of these multiples are also in a pattern, a repeating pattern. These are a couple of patterns that you can observe in the multiplication table of 5. Now let's see the multiplication table of 9. Now in the multiplication table of 9, observe the multiples. This 9 can be written as 0, 9. Now observe the ones digit in each case. The ones digit seem to be the numbers from 9 to 0 written in decreasing order. See, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. The ones digit is the numbers 9 to 0 written in decreasing order. Now what about the tens digit? In the tens place you have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the tens place you can see the numbers 0 to 9 written in increasing order. And also note that the sum of the digits in each multiple. 0 plus 9 equals 9, 1 plus 8 is equal to 9, 2 plus 7 equals 9, 3 plus 6 equals 9. So the sum of the digits in each of the multiples is equal to 9. So these are 3 patterns that you can observe in the multiplication table of 9. Now let's talk about some patterns in division. You see the table here? Find the pattern and fill in the blanks. Let's observe the numbers. 111 divided by 3 equals 37. In the next column you can see 222 divided by 6 equals 37. See? So both the dividend and the divisor has doubled, but the quotient remains the same. Here, after 222, here the dividend becomes 333 divided by 9. Here, the dividend and the divisor has tripled from that of the first division fact. The first dividend was 111 and it has tripled in this case. Even then, the quotient remains the same. So it is 111, 222, 333, 444 and the divisors are 3, 6, 9. The next would be, it would be 12. So the divisors follow a pattern which is the multiplication table of 3. 3, 6, 9, 12 and the quotient remains the same. So after 444, the next dividend would be 555. Divisor 15 and the quotient remains the same. After 555, it would be 666. Then divide by 80, which gives the same quotient. After that, it would be 777 divided by 21. Then after 21, what would be the divisor? So it's 18, 21, next would be 24. So 888 divided by 24 gives you the same quotient, 37. So this is an example of pattern in division. Let's do one activity. This is from page number 117 of your textbook. You can see this heading, try this. Observe the pattern and fill in the blanks. Let's observe the numbers. The first one, 3 into 19 is equal to 3 into 20 minus 3. It means the same thing. Here you have 3 19s or 19 3s, and here you have 20 3s or 3 20s minus 1 3, which is the same as that of 3 19s or 19 3. So here it is written 3 into 19 equal to 3 into 20 minus 3. And what is 3 into 20? 3 into 20 is equal to 60. And 60 minus 3 is equal to 57. In the second line, it is written 4 into 19, which can be written as 4 into 20 minus 4. Now, 4 into 20 equals 80, and that minus this 4, that is equal to 76. Can you fill in the next line? 5 into 19, it can be written as 5 into 20 minus 5. Now what is 5 into 20? It is equal to 100 minus 5, and that is equal to 95. Now the next line, 6 into 19. 6 into 19 can be written as 6 into 20 minus 6. Now what is 6 into 20? It is equal to 120 minus 6. And what is it? It is equal to 114. And do you see some kind of pattern in the final answers? See the ones digit of the numbers here, 7, 6, 5, 4. See, the numbers seem to be in a decreasing order. And what about the tens digit? 5, 7, 9, 11. Here the numbers seem to be odd numbers arranged in the increasing order. So it follows a pattern there as well. So you can fill in the next lines yourself. You can do this in your textbook itself. Let's move on to one more activity. This is from page number 119 of your textbook. It's under the heading Horse. It's a high order thinking skills question. Let me read the question to you. Observe the pattern in the first figure and fill in the circles in the other two figures by following the same pattern. And the first question, the numbers are already filled. You have to observe these numbers to find some kind of pattern. And you have to use the same pattern to fill in the circles in the other two questions. You can pause this video, finish doing this activity and come back. Hope you are done with that. Now let's discuss the questions. So in the first case, observe the numbers 50, 100 and 150. 50 plus 100 is equal to 150. That 150 we have here. And is 100 plus 150. That is equal to 250. Now these numbers are added to get the number on the top. 150 plus 250 is equal to 400. Use the same pattern to fill in the circles in the other two questions. So let's add these numbers 18 and 25. And that is equal to 43. It's already given there. Now the numbers 25 and 15. What is 25 plus 15? 25 plus 15 is equal to 40. Now we have to add this 43 and 40, which is equal to 83. So we have solved this question. I hope you got this one correct. Now let's move on to the next one. Here you have the numbers 30 and 10. 30 plus 10 is equal to 40. That you can write here. Now you have the number 10, but you don't know what is the number here. But the sum is given, which is 50. So let's subtract this 50 and 10 to find out the number here. 10 plus something equal to 50. So how would you find this one? 50 minus 10, and that is equal to 40. So that this 10 plus 40 equals 50. Now add 40 and 50, and that is equal to 90. So I hope you got this one also correct. Now, as a homework, you have to go through the topic patterns in numbers through pages 115 and 119. Then you have to complete the exercise 8.1. Once you have completed, take a picture and send us through Teams. So that's all for today, children. We'll meet in the next class with a new topic. Till then, bye.